Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signal and System Analysis. In this video, I will show you the solution to sample problem on modeling of electrical system. So for question number 1, you are given this figure, okay, which is an RLC circuit, and you are asked to determine the differential equation that represent this system. Okay, so if we look at this system, we can actually apply the Kirchhoff's voltage law to determine the differential equation that represent this system. Okay, so if we do the loops, okay, inside the circle here or inside the circuit here, okay, we can see that we go around. Okay, so first we see this supply voltage V of t. We see the negative sign first. Okay, so we will have minus V of t, and then we go around the loop. We have plus VL, which is the inductor voltage, plus the resistor voltage, plus the capacitor voltage equals to 0. Okay, so we can rewrite this equation so that we have the VL plus VR plus VC equals to the supply voltage, which is V of t. Now this equation, okay, is not yet a differential equation. So we have to represent these voltages in terms of differential equation. So if we look back at our slide, we have this table, okay, that gives us the relationship between voltage and current for each of the electrical components: capacitor, resistor, and inductor. And so if we have the capacitor voltage, for example, in terms of current, it will be 1 over C, the integration of current. For resistor is R multiplied by current, and for the inductor is L multiplied by the first derivative of current. So if we apply this into our solution here, we will have this one. The inductor is L d IT over dt. Okay, this equation is true because we know that current is flowing inside the circle, the circuit. So here we have RIT plus 1 over C integration from 0 to t. This is current, so it's I tau t tau equals to V of t. Okay, so here it looks like a differential equation now. However, we have this integration part. Okay, so the next step is we want to eliminate this integral part. Eliminate the integration using derivative or differentiation d over dt. Okay, so we have to differentiate the whole equation. So if we do that, this one will be a second order derivative because now we have a first order derivative. So this will be d square I of t over dt square plus differentiate current. So you have R di of t over dt plus, now this integration will be eliminated by the differentiation. So you will left with 1 over C I of t equals to d V of t over dt. So this is the differential equation that represents our RLC circuit over here.